Everywhere today, roads are being improved and modernized. New roads built, old roads rebuilt, concrete roads, macadam roads, and good gravel roads. But we still have plenty of just plain roads. And even the smoothest looking roads are often deceiving. Such roads show on examination long waves which can't be seen from the driver's seat. When motorists drive slowly over such roads in yesterday's cars, they get a smooth, easy ride. But as soon as they speed up, the camera shows you that cars are bounced around with a great deal of discomfort to the passenger. That's because there are two sides to this problem of riding ease. First, the size of the waves in the road, and second, how close they come together. When you drive 60 miles an hour, you're going a mile a minute. And if there are 80 long waves in a mile, you're jolted around 80 times a minute. Too fast for comfort. But with modern spring suspensions, motorists travel over such roads in comfort at any speed. For many years, engineers worked on this problem of easy riding from every angle. Springs were studied. They were made short, then long, narrow, then wide, with blunt ends and tapered ends, and they were made of various kinds of steel. The first marked improvement in spring ease came long ago when they discovered the great advantage gained when the springs were set parallel to the frame, with the springs in line with the direction of the ride. Instead of crosswise and contrary to it, side sway is reduced to a minimum. At first, engineers tried making both front and rear springs equally flexible, but they soon found that the front springs would have to remain much stiffer than those in the rear. This was because the front springs had two jobs to do, while the back springs were busy with only one job, smoothing out the road. Besides springing the car, the front springs had to be stiff enough to hold the front axle steady for steering. As a result of stiff front springs and soft, flexible rear springs, when a car passed over the waves, the front end of the car moved up and down faster than the rear. This made a very uncomfortable pitching motion in the back seat. Everyone knew that the front seat rode better than the back seat, so engineers tried moving the back seat forward, nearer the front seat position, to improve its riding comfort. But when they compared the angle of the car at the top of the bounce with its position at the bottom of the bounce, they found that the car went up and down as if it were on the end of a long lever fastened at a considerable distance in front of the car. Therefore, though moving the rear seat forward was a step in the right direction, the improvement was so slight that it was thought more could be accomplished in some other way. One special experimental test car had ridden easier than any of the others, but the design had been discarded because of steering trouble and several other difficulties. The engineers examined this test car more closely to see how they might correct the difficulty in steering. They discovered that the engine had been placed too far forward. There was too much weight over the front axle. So they moved the engine back far enough to prevent all interference with steering. With the weight nearer the middle, the car is easier to control and can be steered with less effort. The car is also safer to operate at high speeds. It's easier to turn and easier to keep straight. Another thing, with less weight over the front axle, the front tires and brakes don't get as much wear as they did. More weight on the rear wheels helps the tires grip the road much better, especially on wet or icy roads, and makes the car safer in an emergency. But the engineers found that with the engine moved back, the car lost some of its riding ease. However, they knew that the more weight that is placed on a spring, the slower it will bounce. That was why the test car rode better with the engine forward. The extra weight over the front axle slowed up the front spring. But Chevrolet engineers could not be satisfied with anything less than riding ease plus control and steering ease too. So the problem was to figure out some way of making the front spring as soft as the rear spring without losing the great advantage of proper weight distribution. The front springs should have only one job. They should not have to help in steering nor in supporting the axle as the old leaf springs did. So the axle has been put over instead of under the springs and made stronger than ever. Coil springs are used in place of the leaf springs. They are fully enclosed. And now both front springs work independently. Now that the front springs are made just as soft as those in the rear, they don't have anything to do except make the road smooth and the passengers comfortable. These new springs have been tested and found to be the biggest single improvement ever made in riding comfort. Now, with this new spring harmony, the rear seat can be placed so as to give plenty of room for everybody to ride with the same comfort, front or rear. And even more has been accomplished. Now the front end of the frame is even stronger than when the old type axle is used. And the tensile strength of the connection between each front wheel and the frame is 3 times as great as the old spring leaf. Another thing, steering is a lot easier. The new construction absorbs road shocks before they can get through to the steering wheel and the driver's hands. Then too, in case of front tire blowouts, the car is much easier to control because the individual spring takes up the quick drop. This car, traveling 60 miles an hour, has a dynamite cap on the front tire. Watch this now. They're going to set it off. Even under that terrific test, the driver still has full control of the car. How's that for safety? With this spring design, the motor, frame, and body are all better protected from strain and vibration. Instead of being pitched up and down as the car speeds over the road, you ride smoothly without the uncomfortable pitching of the passengers and the jarring and jolting of the car. With less strain, every part of the car lasts longer and operates more smoothly. Of course it costs more to put these new springs on a car, but the advantages they offer in a safer and more comfortable ride makes it more than worthwhile, and the longer life of the car itself offsets their cost many, many times, making a great saving to the owner. With this advanced spring harmony between front springs and rear springs, every highway and every road invites speedy, safe, and comfortable travel.